Hello students, welcome to my YouTube channel. In this video lecture, we are going to continue solving the questions from Keith Williams' Weight and Balance book, and the chapter name is Basic Questions. So this is the very first chapter. There are some 120 basic questions modeled on the definitions, conceptual understanding, some formulae, some simple numericals. So far we have done the first 70 questions, and in this video lecture we are going to do the next 10 questions, 71 to 80. So let's start. What is the standard baggage allowance for passengers on aircraft with more than 20 passenger seats which are operated on domestic flight routes within joint aviation rules airspace, that is European airspace? So the baggage allowance for domestic flights is 11 kg. Baggage allowance on European flights conducted within the Europe, is equal to 13 kg, and flights of and intercontinental flights, the baggage allowance is equal to 15 kg. Okay, so remember these three values. Next, which of the following best defines the term takeoff mass? Gross mass minus trip fuel, ramp mass plus startup and taxi fuel, ramp mass minus startup and taxi fuel, landing mass plus total fuel. So let's say this is your runway. Okay, here is your runway 009 and 27, and here is the ramp. Your aircraft is located on the ramp where fueling happens, correct? Where fueling of aircraft happens, passengers are boarded, cargo is loaded, everything. So when your aircraft is on the ramp, it will be at its maximum mass, right? Because at ramp, its fuel tanks will be filled with fuel. The fuselage will be full of passengers, cargo, baggage. So at the ramp, at this position, the aircraft will be the heaviest. Now, when it goes from the ramp, when it starts taxiing from the ramp and goes to the runway, like this. So during this journey from the ramp to the runway, it will burn, it burns startup fuel, the fuel used for starting this aircraft. So burn startup, and then it will also burn all the taxi fuel that is consumed during the taxi. So it burns startup and taxi fuel. So you are finally left with, here you have here you had ramp mass. And when you burn all this startup and taxi fuel, you will be left with takeoff mass. You will be left with takeoff mass. So takeoff mass is equal to ramp mass minus startup and taxi fuel, because this startup and taxi fuel will be consumed much before you reach your takeoff location, takeoff position on the runway, right? So ramp mass plus startup taxi fuel, wrong. Landing mass plus total fuel, again wrong. Landing mass plus trip fuel will give you takeoff mass, but not the total fuel. Total fuel means what? Startup fuel, taxi fuel also. So that should be excluded from takeoff mass, not included. So that is wrong. Gross mass minus trip fuel, that is wrong. So 72 Charlie. Ramp mass is what? So like I said here, ramp mass is the mass of your aircraft at the beginning, in the very beginning when it is parked, where fuel tanks, fueling happens in the fuel tanks. Passengers start boarding your aircraft, cargo is loaded, etc. So ramp mass is gross mass, the total mass, plus an allowance of fuel for startup and taxi. That's wrong. This ramp mass is inclusive of all fuel components, like all fuel components, startup and taxi fuel, takeoff fuel. Now this takeoff fuel is nothing but your trip fuel, right? Trip fuel, then alternate fuel, diversion fuel, contingency fuel, extra fuel, all that. So ramp mass is inclusive of that, so you need not add or plus additional fuel for startup and taxing separately. Gross mass immediately before startup, gross mass before taxing, gross mass on arrival of the unloading run. That's wrong. So correct answer is option Bravo, before engine startup. Next. Which of the following statements about maximum allowable landing mass is most accurate? The maximum allowable landing mass is another term or another label for regulated regulated landing mass. Is another term for regulated landing mass. And okay, and this regulated landing mass or maximum landing mass means the landing mass limitation you're going to choose for your flight. Now you will have two different types of landing masses. One will be the maximum structural landing mass specified by the manufacturer, and another one will be performance limited landing mass. Okay, so the landing mass which is controlled by performance determining factors like fresh altitude of your airport, whether your airport is at mean sea level, near mean sea level, or very much above the sea level on mountains. Temperature, weather temperatures, ambient temperatures when you reach your destination will be warmer than ISA or colder than ISA. The available runway lengths, the condition of the runway, if it's rain, so the condition of the runway will be wet. Again, humidity of air, density, altitude, right? So all these conditions will again influence your landing mass limitation. So this particular landing mass will be called performance limited landing mass. Now the landing mass that you are going to select for your consideration will be the lesser of one which is the lesser of maximum structural landing mass and performance limited landing mass. If maximum structural landing mass is 40,000 and performance limited landing mass is 37,000, so the landing mass that you are going to consider for your calculations in your calculations will be performance limited landing mass, which is 37,000. Always choose a lesser value. Even deciding a regulated takeoff mass, you are going to select a value which is the lower of the less of maximum structural takeoff mass and performance limited takeoff mass. So the correct answer here is it is the lower of maximum landing mass and performance landing mass, lower of takeoff mass, maximum takeoff mass and performance landing mass, always less than maximum landing mass. No, your regulated landing mass can be uh, more than maximum structural landing mass also. So it depends. Okay, so it is never less than maximum landing mass. So that is also wrong. The correct answer is lower of maximum landing mass and performance limited landing mass. Next. When they talk about maximum landing mass, they mean maximum structural landing mass. Okay. 75. The maximum allowable landing mass and the regulated landing mass are never equal, are sometimes equal, are the same thing, sometimes greater than performance limited landing mass. So the correct answer is they are the same thing. Like I said, maximum allowable landing mass equals to regulated landing mass. Which of the following best defines the useful load of aircraft? So we always start with the basic empty mass, which is the standard empty mass of your aircraft. Now when you add variable load to this basic empty mass, you get variable loads added to basic empty mass produces dry operating mass. Now dry operating mass plus takeoff fuel or fuel on board equals to operating mass. Okay, dry operating mass plus payload will be equal to zero fuel mass. Operating mass plus payload will be takeoff mass. Again, zero fuel mass plus fuel on board will also be equal to takeoff mass. Another way to find takeoff mass is dry operating mass plus useful load, okay, equals to your takeoff mass. Now, what is useful load? Useful load is nothing but fuel on board plus payload. Fuel on board plus payload equals to your useful load. So, useful load, the part of the payload for which operator receives payment, that is wrong. Okay. So now traffic load. Now here they have used the word payload. That's fine. Sometimes they use it interchangeably. Traffic load equals to payload plus the non-revenue load. Now payload is inclusive of passengers, cargo, baggage. Okay, so these three things will generate revenue for your commercial aircraft company. But the non-revenue load that your aircraft is carrying in the cargo section, maybe this load belongs to the company itself, so company won't charge itself, right? So non-revenue load will not generate any revenue for the company. Okay, so the part of the payload for which operator receives payment is your this payload, passenger cargo baggage. But useful load doesn't mean that. Next, DOM minus reserve fuel, wrong. Traffic load minus strip fuel, wrong. Traffic load plus usable fuel, that is takeoff fuel, yes. So traffic load or payload plus fuel on board, also known as takeoff fuel, equals to usable load, right? Next, the distance between the center of gravity of a load and the datum is called, so let's say this is your aircraft. This is your aircraft. Now on this aircraft there will be one forward limit and one rearward or backward limit within which the center of gravity can move without making your aircraft unsafe. Okay, CG. And let's say there is a datum here. Now datum is an imaginary plane from which all center of gravity calculations are made. So now the distance between the datum and the center of gravity of an object is called balance arm. Balance arm. Okay. So the distance between CG and the datum is balance arm, moment, load index, load station number. So balance arm. Next. CG of an aircraft is determined by the regulator, is determined by the manufacturer, may move within a set range. The forward limit, the backward limit is determined by the location of the traffic load. So option Charlie. The center of gravity, now this range that we are talking about, the forward limit, the aft limit, this range is determined by the manufacturer. And the center of gravity is calculated before every flight by the captain, by the pilots. Okay, before every flight you must do this center of gravity calculation and make sure, check that the center of gravity falls within this acceptable range throughout the flight at the time of departure, cruise, landing. Okay, so the correct answer is CG may move within a set range, determined by the regulator, no, determined by the manufacturer, no, determined by the traffic load, no. Next, the center of gravity datum of aircraft must be on the longitudinal axis, and within the nose or tail of aircraft must be on the longitudinal axis, but not necessarily between the nose and the tail, can be anywhere, must be either at the nose or at the rear pressure bulkhead. So the look at this datum that I have drawn here. Now this datum falls outside aircraft, okay, but it's still on the longitudinal axis of aircraft. It's still on the longitudinal axis of aircraft, which is nothing but an imaginary line that begins from the nose of aircraft, ends at its tail, right? So this datum can be anywhere on the longitudinal axis of aircraft. Second point, it can be inside your aircraft or it can be altogether outside your aircraft. but it must be on the longitudinal axis. Now it cannot be anywhere. It cannot be on the lateral axis or the vertical axis. Okay. So the correct answer here is must be on the longitudinal axis, condition number one, but not necessarily between the nose and the tail. It can be outside that. Useful load is what? Takeoff mass minus operating mass. So what is takeoff mass minus operating mass is payload. Correct? It's not useful load, it is payload. So option alpha will be the wrong one. Takeoff mass minus DOM, yes. Takeoff mass minus dry operating mass, yes. So takeoff mass minus dry operating mass is useful load. Next, full load plus basic empty mass, we do not have any such equation. We have basic empty mass plus variable load that gives us dry operating mass. Takeoff mass minus fuel load is not useful load. What is it? So let's check. So takeoff mass minus fuel on board or takeoff fuel gives you zero fuel mass. It doesn't give you useful load, it gives zero fuel mass. So option delta is also the wrong one. So option Bravo is the correct one. So for that you must know that flow chart by heart. Once you know it by heart, you remember that, and you will be able to solve any such question, formula formula based question like this. The definition, simple. So with this, we come to the end of this lecture. I hope you have understood all the 10 questions that I have solved. All of them were theoretical, no numerical in this particular lecture. So good. And I suggest that you practice all payload questions from RK Bali and from Keith Williams. I have solved all questions of payload from Keith Williams and uploaded to a particular playlist called Keith Williams Weight and Balance playlist. So do all the 100 payload questions that I have solved. So do it with me. You will come to know how to solve these payload questions, the different ways in which they can ask payload questions. So you will get familiarized with the payload concept. And payload questions are always asked in CPL, ATPL, airline exams. 5, 6 questions are always there, numerical questions. So it will be a very good thing to solve all the payload questions from Keith Williams, RK Bali, and Oxford. So best of luck. Don't miss my next video lecture in which I will come to solve the next remaining questions from this particular chapter. So I hope to see you there. See you.